Hello, welcome. My name is Daniel Chu with Seiko Geekin. Thank you for your interest in our optical e-field sensing system. We are happy to provide you with an evaluation unit for testing purposes to see if we can help with your application of submersible e-field sensing unit for hyperthermia applications. That being said, during this period of instruction, I'm going to cover three main areas. Number one is going to be the kit contents. Um, Number two is going to be how to handle the sensors in the fiber and how to do the cleanings. And number three is going to be how to do the integration of the system. So that being said, let me jump right in to the kit contents. When you first open the box, you're going to see this list of supplies here. And if you would please, when you receive the unit, check the inventory of the evaluation unit against this list of supplies. We want to make sure that nothing was lost in transit and that you received everything in good condition. So that being said, I'm going to go through this list of supplies here just to show you exactly what everything is. The very first thing you'll see on here is the optical probe head, which is PH0255 is the product code. That's going to be hidden in the back of the main big box that we're shipping you, and it's going to be shipped in a James Bond looking lunchbox like so. I'm going to go ahead and open this up just to show you what exactly it looks like here. So this is our James Bond box. Inside of here is the probe number. There's one right there, 0455M, and the other unit is 0255. And you can see those are the first two items listed on the inventory list of supplies. The next thing listed on the list of supplies is the optical probe head 0655, which is in this black box here. And you can see once you open the box, it's going to look exactly the same as the previous two. Now these are essentially the same type of modulators that you're going to be using for your application, except these are packaged into SMA connectorized probes. So these are good for passive antenna measurements, MIMO applications, or measuring the electric voltages with like an oscilloscope probe or something of that nature. Now, the next item on the list is the noise leak detector head, SH03ND. This is going to be the unit that you're going to be evaluating, okay? Reason being is this is the actual modulator that's going to be in the sensor that we're going to be building for you. This one is a commercialized sensor that's designed for really tight spaced applications, such as the internal component or the internal electric field of a hard drive. So you can actually, we designed this to fit in really small spaces. You can see here it comes packaged in this plastic container here, and you slide the cardboard off. This is the actual noise leak detector here, and this is the foam piece just for shipping, but the connectors or the sensors here. So you always want to handle these by the sensor head, which I'm going to get into in a minute. The next item on the list is the isotropic e-field sensor head SH03EX. That's here in this blue container, this blue little looking lunchbox. This is the item that we previously discussed. You can test this if you want to. That's why I'm sending it to you. But you would need the positioning jig for that, which I'm going to show you here in just a minute. This is the SH03EX. Has three different channels, channel 1, channel 3, and channel 2 there. Again, you want to handle it by the head. The next unit is going to be the controller, which is what you're looking at right now, C31055. AC power cables, that's connected to the back of this right now. You know what that looks like. Optical fibers times 3. That's going to be this guy here. It's one cable, but it's 3 fibers together on it. So Next, you'll see 3 optical adapters. Those are going to be packaged in a little bag by themselves, but this is what they look like. One software. I'm not going to take it out of the packaging, but this is the software disk, which you'd be using for GPIB interface, automated measurements, automated switching of the channels. And then the next one is going to be the fixed jig, which is this unit here, which is what you would use with the SH03EX isotropic sensor to make measurements. I'll show you how that integrates in a second. And lastly is the operation manuals. So you're going to be receiving 3 operational manuals. If you have any questions during your evaluation, you can always refer to these manuals. This is for the OEFS. This is the isotropic sensor. This is for the optical probes, which is the SMA connectorized probes I showed you. And the noise leak detector, which is the small guy that you're going to be doing the actual evaluation of. Okay, so let's start with how to handle the probes. First things first, when you handle the probe, you're going to want to always handle the sensors and the probes by the actual head itself. This is the most durable part of any fiber. Okay, the most delicate portion of the fiber is going to be where the actual fiber adheres to the modulator, which is in here. It's right about here, but you can see we've ruggedized the probes. We know a lot of antenna guys that are used to working with coaxial, so we've done our best to ruggedize them for commercial purposes. But obviously it's fiber, so you always want to maintain delicate care with them. Now the next one is the sensor head that I want to show you, the SH03EX. I'll show you how this fits into the positioning jig, which is here. See, on the positioning jig, there is a, this is the front of it here, and where you're going to be sliding the sensor down into. There's this black line, and that's where you're going to want to align the single side of the channel 1 on the prism on the back of the sensor. I know that doesn't make sense right now, so I'm going to just show you. So on the sensor, you can see on the back here, there is channel. There's the triangle or prism, and what you'll do is you'll align channel 1 here with this black line. Okay, so channel 1 there. And now when you're making your measurements, channel 1 is going to be your perpendicular axis. Channel 2, your x-axis, and your y. Here's channel 3. Okay? Now the noise leak detector, this is how it comes packaged for shipping. You're going to want to take it out of the styrofoam here for your measurements. This has the same modulator that we're going to be using in the custom sensor that we would develop for you. Obviously, it's going to be more ruggedized and in a more well-formed package. This is done, again, just for specific application. However, this is going to give you the same technical performance of the other sensor, the custom sensor. However, in the custom sensor, you'll have a 3-axis isotropic measurement versus this is just a single channel. But we're hopeful that you'll be able to acquire enough information during your evaluation to see if this performance is going to be optimal for your application. We do ask that when you weatherproof it or waterproof it, just please check the bag to make sure the bag's good and waterproofed. I recommend you try to vacuum seal as best as possible. I guess the air inside of the bag could cause a dielectric effect. So if you can vacuum seal it, great. But just try to waterproof it the best as you can. Obviously, we're sending this unit to you without a sales engineer or myself to accompany it. So we are going to absorb the risk of possible damages. So we're not going to hold you accountable for it. Just please handle with care. Okay? Thank you. Now, the next thing I'm going to show you is going to be the control unit. Now, the control unit is what you're seeing right here. This is a C3-1055. You'll have similar. Yours is a 3 gigahertz model. It's going to look exactly the same as this. This is the 10 gigahertz model. This is the front panel. When you turn the power button on, everything will illuminate green at first. It's going to do a self-diagnostic on internal components, and also it's going to be checking the insertion loss of your fiber lines. If the insertion loss is too great on any of the fibers, what's going to happen is it's going to trigger this optical alarm here, and that light is going to illuminate red. And what that does is it shuts down the laser diodes, and you won't be able to make any measurements. So what you would need to do is check all of the fibers, make sure that all the connectors are properly seated and that the connectors are clean, and then you'll hit this reset button and it'll automatically cycle through again and do another test. If it's good, this light will turn green. If the fault condition still exists, it's going to stay red, and you'll have to escalate the troubleshooting process. So that being said, once you turn the power button on and it goes through the self-diagnostic test, it's going to automatically default to channel 3. So when you're testing with a single access unit, just go ahead and plug it into channel 3. That way, you don't have to manually switch it every time you turn the unit off and on. It'll automatically be defaulted to channel 3. So it's just convenience purposes. Now the next on here is the local remote switch. This is used for the GPIB interface for automating your measurements, automating the channel switching between 1, 2, and 3. I don't believe you're going to be using this for your evaluation, but if you do want to get the full taste of the system and the software, go ahead and install the software into your PC, and I can send you the programming codes for the GPIB interface. It's pretty straightforward. If you don't want to do the automated process and you're going to be testing 3 channels, you can just also manually switch between the channels on the front panel. Okay, so sensor select section, you can do manual switching. You also have the adapters as to where your fiber is going to connect for each channel. This is a dust cap. Each one of these channels has it. Please, when you're not using the system, try to keep the dust caps in there. That'll keep any debris or dust from getting the adapters or connectors dirty. Okay. Next thing I want to show you, these are also, each one is an input and an output. The optical signal comes in and then it goes back out. So that's the sensor select section. Now on to the RF out. This is a standard 50 ohm output to your measuring device. So what you would do is hook up a phase stable cable directly from here to your spectrum analyzer or your network analyzer or your oscilloscope, whatever it is, whatever measuring equipment you're going to be using. This that has a 50 ohm input. This is going to be your source here. Okay. Next thing I want to go to is show you. Now, obviously, with each one of these units, each one of these sensors we're shipping you, you can see the fiber is not very long. I believe it's only a meter for each one. That's not going to be long enough for you to reach your measurement setup, I assume. So what you'll do is you'll use our extension cables that we provided with you, that we provided for you. I believe this is 10 meters of extension cable. There's channel 1, channel 2, and channel 3. What you'll do here is they're even labeled sensor head side or controller side. Okay, so what you'll do is you'll just take channel 3 on the controller side. These are SC APC connectors, which is Sam Charlie, APC, which is angled physical connector. And what that means is that the ferrule end face has a 8-degree polished end face for maximum connection and performance. But what that also means is you have to, because that's angled, when you plug it into a connector or an adapter, you're going to want to align this fiber guide into the fiber guide of the adapter you're going into. So you can see here, this has a slot to align with this. So now when you go to plug it in, just grab it by the head here, push it in. Okay. If you can still see white, if you can see that white line, that means that you are not properly seated. So what you want to do is you want to push it in until you hear that audible click, and you can see that the fiber guide is all the way in and there's no white line. You should have a good connection on there. And that's channel 3 aligned with channel 3. Pretty straightforward. Now on the other side, when you're hooking up your sensor, you're going to have channel 3 on the other side of the cables. Channel 3 here, okay. And what you'll do is you'll take first your adapter, your channel 3 adapter. Take the dust cap off of that. Take the dust cap off of this connector. Again, when you're not using these connectors, please keep the dust cap on it. It'll keep people from scratching the end face or the end face even getting dirty. Even a fingerprint on there can affect the performance. Okay. So now you'll align this guide into the slot. Same thing. And now on the other side, when you're connecting your sensor, take the cap off, and you'll want it to. So now what we've done is we've got the sensor here connected to the adapter using the extension cable all the way back to the controller. So you can see everything's connected. We still have the optical alarm button, which means that you're not going to be able to get any measurements out of you're not going to have any output of your RF out here. So what you'll do is you'll hit the reset button and want to cycle through the diagnostic again. You should get a green light, which we do, which means that the system is fully operational now. There's no breaks in any of the fiber, and you should be able to get good measurements. That being said, let me jump right into how to do the proper cleaning of each one of these connectors in case you do still have an issue. Like if, for instance, if somebody touched the fiber like this, there's a good chance you're not gonna. Okay, well my hands must be pretty clean. But either way, if the fiber gets dirty, you're gonna use. This wasn't included on the packing list, but I'm gonna put it in there as well. This is a cleaning tool that we use, that we manufacture for cleaning connectors and adapters. So what you'll do is you'll see here there's a little arrow on the end of this sticker, and that's for APC connections. So again, because the connector is angled, because the ferrule is angled, you'll want to align that guide with that arrow. So when you're cleaning your connector, you just put this in the end here, push in a little bit, just light pressure, not hard. Give it a couple keys with the cleaner, and your connector should be spotless clean right now. Okay, so 2 or 3 swipes is fine. Plug that back in. On the adapter side, if you feel like you need to clean one of the adapters on here or the adapters that we gave you, what you'll do is you'll take the same cleaning tool and you remove the whole cap. And what that does is that exposes the internal cleaning cloth here. And so what you'll do is you'll align that APC sticker with the fiber guide, give it a couple cleanings again, and you should be good to go. That's how you properly clean the fibers and the connectors. That's pretty much it. It's a straightforward deal. If you have any questions at all during your evaluation period, please feel free to reach out to us anytime. You can call me anytime or send me an email. We're happy to support you any way possible. Other than that, thank you for your time. We look forward to getting the results of your evaluation. All right, take care.